Hello friends, how are you? Hope you all are very fine. So today we are meeting again for another class, and today's class will be a very important class. That is, we'll be studying the naming of the organic compounds. So I was having a lot of requests from my students to provide for this class. So I'll be today teaching you organic compounds, how to name organic compounds. So let us start this, and before that I'll tell you that please subscribe my channel and like my channel so that you keep getting the notifications, and whatever important chapters you are not able to understand properly, you can send me the requests of those chapters, class 10, 11, 12. Okay, I'll try to upload those classes so that it gives a little bit benefit to you. So as already I had a talk with you that I'll be uploading a class every day. So I'm trying to upload the classes for which I'm getting the requests. So today I'll be doing the class of naming of organic compounds. So let's start that. Naming of organic compounds. Naming of organic compounds. So this is a very important chapter in chemistry, because if you are not quite confident about naming the compounds, then it will be a problem for you, the chapter of the carbon compounds. So I hope that after seeing through my class, it will give you some benefit. So let's start. Okay, we know that carbon has got atomic number 6. That means if I do the electronic configuration, it is 2, 4. That means carbon can attach at a time with 4 other elements. Now those elements can be hydrogen, can be chlorine, can be bromine, can be any functional group, I'll be dealing with those. So carbon has got 4 electrons in the last shell, and that's why carbon does covalent bonding. That means it will share its bonds, it will share its electrons with other elements. It will neither give electrons like metals, nor it will take electrons like non-metals, but it will try to share electrons with other elements and form covalent bonds. So those covalent bonds can be with carbon, with any other elements. So today I will show you how to name the carbon compound. So let's start it. Now this chapter is itself a quite very interesting chapter because it doesn't require any memorizing. It requires some logic. So what is the logic? Let's start. First of all, we will see that if there is only one carbon atom, if it is one carbon atom, the name will start with meth. 2, it will be ith. 3, it will be prop. If there are 3 carbon atoms, prop. 4, it will be but. 5, it will be pent. 6, it will be hex. 7 is hept. 8 will be oct. 9 will be non. 10 will be dec. Now I'll be dealing till 10 because you don't have more than 10 in class 10 level. So I'll be dealing with this. Please note it down that the number of carbon atoms, as per the carbon atoms number, the name will start with these. Okay, so this is the initials. And now if you are having the carbon to carbon single bond, then the name will be, those are alkane groups, and we will choose here from here A. We will choose the A, or sometimes we choose an. Alkanes A or an. Similarly, if carbon to carbon there is a double bond, we will choose the alkene, they belong to the alkene group, and we will choose the ENE, or sometimes only EN. Sometimes only EN. And when we have carbon to carbon triple bond, then it belongs to the group alkyne, and we choose the word from here is YNE. YNE. So these are the basic things. The number of carbon atoms, these are the names. And if the carbon to carbon bonds are single bond, alkane group will choose N, double bond ene, and triple bond will choose the ine. Similarly, there are more things that carbon will be attached. So let's see one by one. Please keep noting down whatever I am showing, or you can go through my video time and again as many times as you like, because what will happen is that my lectures will be enough for you to get the confidence. So please go through the videos, and that is why I am uploading it. So now, if chlorine is attached, the name will have chloro. Bromine attached, it's bromo. Fluorine will attach, it's fluoro. Iodine will attach, it's iodo. And then we have got functional groups. We have got functional groups which actually determine the nature of the carbon compounds. They determine the nature of carbon compounds. Basically, they will determine the nature of the carbon compounds. So what are the functional groups? Number one, if OH gets attached, it is actually alcohol group, and we will choose the word OL. Similarly, if C double bond O H is attached, C double bond O H is attached, it is an aldehyde group. And we will choose the word nal. Similarly, if C double bond O is attached, it is a ketone group, and we'll choose the word on. Similarly, if C double bond O and OH is attached, it is an acidic group. And we will choose the word oic acid. Similarly, we have got more groups. We have got the nitro group, NO2 group. It's a nitro group. Okay, so the word nitro will come. So here, in this case, what we will see, this is already, it's not there for class 10 level. So basically, you don't need to concentrate on this. You have to concentrate mainly on these. OH, C double bond OH, aldehyde group, C double bond O, it's a ketone group. C double bond O, OH, it is an acidic group. It's an acetic acid group. Okay, and the name will end with oic acid. So let us see how the naming of the carbon compounds will be there. So let's show you some examples, and then you will be able to understand. First of all, our target will be to choose the longest chain of carbon atoms. Longest chain of the carbon atoms. Second is, we will give the preference to the functional group. I just showed you alcohol, aldehyde, ketone, those. We will give the preference to the functional group attached to the chain. Third is, we will give preference to the bond. What bonds? First preference will be the triple bond, then will be the double bond, then will be the single bond. Carbon to carbon. Triple bond, double bond, and then the single bond. These are the preference wise. And then we will give the preference to the attached groups. For example, we will give, this is the methyl group, this is the ethyl group, and then we have groups, as I told you, chloro, bromo, iodo, fluoro, these all. Now, try to understand that if in the attached group, suppose you have the methyl and the ethyl groups, both. You have the methyl and ethyl groups both. Both are hanging. Both hanging. So which one will you give the preference? Alphabetical preference. Alphabetical preference. So what is alphabetical? Now here, eth will come first, then meth will come. First E comes, then M comes. So first we will give the preference to the eth and then to the meth. Similarly, if you have got the chloro group attached, the bromo group attached, the fluoro group attached, so which one will give the preference? Again, alphabetical. Alphabetical order. That means first will come the bromo because it's B, then will come the chloro because it's C, then will come the fluoro in this way. So these are the basic rules with the help of which we will be naming organic compounds. So let's see how it happens. Again, I'm telling you, this is the chapter which is fully logical chapter, and so what you have to do is that please try and see the video as much as possible to get the confidence. Okay, so let's start a simple thing. For example, if I tell this is a chain, let's start here. This is a chain. Okay, so as I told you that all carbon atoms will have 4 bonds. So first of all, see that which one is the longest chain? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. Or 1, 2, 3, 4, 5, 6, 7, 8. That means 8 is the longest chain. So either I can go like this or I can go like this. But I can never choose this because it is giving you 5 and this is giving you 8. So let's start the numbering. Okay. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Now one more thing. I told you this will now become the hanging group. Basically, this is the main chain. So this is becoming the hanging group. In the hanging group, how many are there? 1, 2. So in the hanging group, if there are 2, I told you it is ethyl group. Ethyl group. It is the ethyl group. If it was only 1 carbon atom hanging, it is the methyl group. It is the methyl group. So first of all, let us take here 2 carbon atoms are attached. We can see that. So now what we'll do is that we fill up the carbons 4 bonds. We'll fill up the carbons. This is 1, 2, 3. So it will have 1 hydrogen. This carbon is 1, 2. So it will have 2 more hydrogens here. This carbon 2. So 1, 2. This carbon is 1, 2. This carbon is 1, 2. This carbon is 1. So 1, 2, 3. So these will be filled up with hydrogen, because every carbon atom should have 4 bonds. So you will count out how many bonds of carbon are already linked, and the remaining you will fill up with the hydrogen. This carbon has got 2, so 1 and 2. This carbon has got only 1, so 1, 2 and 3. So this is how we have linked. So now let's see, as I told you, that if I give the number 1, 2, 3, 4, 5, 6, 7, 8. Now, longest chain I have chosen. Second, what I told you, look for the double bond, triple bond and single bond. So there is no double bond, there is no triple bond, and there is only 1 single bond. Okay. Then I told you the hanging group. So the hanging group should have the lowest position. The hanging group should have the lowest position. For the time being, if I remove, so it will be easy for you to understand. It will be easy for you to understand. These hydrogens remain actually. These remain. I'm just trying to make it as simple as possible for you. So for example, mind it, these hydrogens are there. So I told you that this hanging group should be having the preference of the numbering now. Okay. So watch here. If I start from here, 1, 2, 3. So the hanging begins in the 3rd position. Hanging begins from the 3rd position. And if I start from here, 1, 2, 3, 4, 5, and this is 6. So the hanging begins from the 6th position. But we have to give it the lowest position. So this numbering is not valid. We have to hang it from the lowest position possible. So this numbering is valid. 1, 2, 3. So it is hanging from the 3rd position. So now let us see. So there are 8 carbon atoms. 8 carbon atoms is oct. As you remember, 8 carbon atoms is oct. And in the 3rd position, who is hanging? The ethyl. So we will write here 3 ethyl, oct, 8 carbon atoms, and all carbon atoms have got single bond. So alkane groups in. So this is the name, 3-ethyl octane. So this will be the name, 3-ethyl octane. Okay. So let's now do few more. 3-ethyl octane. So let's start now. Let's make few more. So suppose this is the structure given. This is the structure given. So we'll fill up with the hydrogens 1, 2, and this carbon atom has got 3 and 1, 4. This is 3 and 1, 4. This is 2, so 2 more. This is 2, so it will have here. So these are all hydrogens attached. So let's give the name. As I told you, this is the longest chain, and now we will look for the bond. Triple bond, single bond, double bond. So triple bond. So if I start numbering from here 1, 2, 3, the triple bond is in the 3rd carbon. If I start from here 1, 2, 3, so triple bond is in the 2nd carbon. So my numbering will start from here. My numbering will start from here. And so the name will become, so no other hanging groups are there. So preference was given to the longest chain, and then the second rule says it is the bond you have to look for. Okay. So what we will give the name here, it is 1, 2, 3, 4, 5 carbon atoms with a triple bond in the 2nd position. So what I will write, it is pent to ine. It is pent because 5 carbon atoms. In the 2nd position, there is a triple bond is ine. So pent to ine will be the name of this compound. Okay. So let's make it little bit more in terms of the hanging compound. Let's see. So if I have got this, the functional group attached, and I've got a double bond here. So let's give the first, make it the longest chain. This is the longest chain. Second rule says that you have to see the functional group. So we have got a functional group. So we have to give the lowest position. Then we will not see the bond. We will see the first longest chain, and then we will see the functional group attached. So functional group is here. So we will give preference to the functional group. It should have the lowest position. So I will start from here, 1, 2, 3, 4. So what will be the name of this? These are 4 carbon atoms with a functional group attached here, and there is a double bond here in the second position. So the name will be but, because there are 4 carbon atoms. There are 4 carbon atoms. So but, and then but, first of all, but, it is 2 in all. But 2 means in the butane there are second position, there is a double bond. So in and all, this is the functional group. So this is the name given to this carbon compounds. Okay. So let's see one more here. So if I draw like this, and I give O here. So what will be the name of this? This is the functional group attached. This is the functional group attached, and there are 5 carbon atoms. So 5 means, so the functional group preference will be given to the functional group. So 1, 2, 3, 4, 5. So what will be the name of this? It will be, in the second position, it's 2. It is pentanon. It's 2 pentanon. There are 5 carbon atoms. So it's a pent, and this is it's a ketone group in the second position. So 2 pentanon. So 2 pentanon will be all carbon atoms are having single bonds. That is why I told you it will be the alkane group an. Pent means 5 carbon atoms, and on means it is a ketone group. So it's 2 pentanon. This is the name of the compounds. So let's see furthermore. So suppose we have got this compound.